Next concept or concepts we need to get our head around is kernel, processes, threads, and stack. These two things we have almost discussed through the story of Theseus and Minotaur and stuff like that. Very much related to call stack, in fact. So kernel is the operating system itself. Kernel mode is the privileged mode where all the drivers and the operating system itself is running. It has direct access to hardware. All the protected mode operating system has a protected kernel. So that is the kernel all about. So we'll see a lot of drivers and stuff like that soon. Now, from a debugging perspective, kernel debugging perspective, the kernel behaves, the system process behaves like one big process with a lot of threads, which can execute privileged instructions and code of the drivers. That is how the kernel behaves from a debugging perspective. Process doesn't execute anything. Process is nothing but just one big address space. It's like a home. It's like a space which has allocated memory. It doesn't execute anything. Although the name process is a little confusing. Process is in Windows, at least, I think even in Linux. It is mostly pointing to an address space. On the other hand, threads are the ones which does things. So thread is nothing but a sequence of instructions which CPU is guaranteed to execute in that order we are giving. For example, there are two instructions in the same thread, 1 and 2. It'll execute in their exact same order. And there are n number of instructions in different threads. They are not guaranteed to execute in the exact same order. This is also called asynchronous execution. A thread has a stack, and a stack will point to a call stack. Also, a thread has a CPU context, like all the registers and stuff like that. Those are the main things a thread has. So when the thread switch happens, the CPU context changes, the values in the registers changes, and stuff like that. Exception happens always in the context of one and only one thread. Exceptions are nothing but interrupts. So I'm just going a little ahead of the slide, which I don't want to do. So let's focus on what we are here. Threads are nothing but a group of CPU instructions guaranteed to execute in the order we are giving. That is what thread is all about. And thread stack, which is a piece of memory, will help to maintain the order of execution and have local variables. So thread stack has local variables, return address, arguments passed, all these things the thread stack having. Now let's see a quick whiteboard to understand the relation between these entities. So this is the system we are having right here. This is the system. And the system has kernel mode and user mode. This is the kernel. And this is a user. So this is where all the drivers are running. All the drivers have threads. So these are driver threads which is running in the kernel mode. So these are threads. They can access memory here. They can address memory here. Pretty much all the memory they have access to, these drivers. Also they have direct access to the hardware. The hardware is sitting here. They have address to the hardware like disk, graphics card, whatnot. So these are the driver threads, all the operating system threads along with the driver. So driver and OS. Yeah, those are the things which is running inside the kernel. Now in the user mode, we have different applications running. So this is the Notepad which we launched. This is the WinDebug we launched. And then the Hello World application, Word, Excel, PowerPoint, whatnot. Those applications run in user mode, and they cannot normally, unless they are debugging, they cannot access memory each other. This is not possible. They can access only their memory within this space, which is the lower 2 GB of a 32-bit address space. We'll see that as well. So this is a process, and this process also has threads inside. These are threads, user mode threads. So this user mode threads doesn't have access to any memory. It cannot access this memory. It cannot access this memory. It cannot access this memory or any other memory other than this particular box. Each of this thread has a stack. So a stack memory. I'll draw it here. There is a thread here and it has a stack memory. So stack memory comes here inside the process address space. It's a piece of address space, and the stack has all the return address, local variables, and stuff like that. The thread has also CPU registers a copy of the CPU registers. Whenever the operating system switch to that thread, the main thing it does is load the CPU with those CPU registers of that particular thread. Yeah, so we have seen kernel, which is like a big process, and the user mode process, and then threads we have seen. Thread is the one which execute the code, which is like a representation of CPU or representation of CPU slice. And stack is a piece of memory in user mode. In fact, there is kernel mode stack as well. If it is kernel mode, you will have the kernel mode stack.